will be another little academic safari of the Lamiaceae in Southern Africa. Multidisciplinary study, so lots of different components. So I hope that you will find it interesting and hopefully not too cumbersome. So just a background on the Lamiaceae, it's the mint and sage family. For those that might not know, there's some picture of some mint and sage up on the screen. So just a background on the diversity and distribution. Here we can see that the Lamiaceae is a prevalent family that occurs globally, almost in all parts of the world. It's made up of 250 genera, encompassing about 7,825 species. So here are some of the most notable species in the family: lavender, basil, mint, and sage. And you can see photos of them up on the screen. So what makes this family so important? Well, they are producers of aromatic volatile oils that are used as aromatherapy and other treatments, alternative treatment, should we say. Used as culinary spices and herbs, flavoring meats and dishes all across the world, used in perfume and cosmetics, as well as the Western pharmaceutical and medicinal trade. So the last update of the Lamiaceae in Southern Africa was done by a gentleman named Codd in 1985. And we recently published a review of Southern African Lamiaceae where we updated the taxonomy, as a lot of the species had been renamed and moved around. And we also looked at the chemical and ethnobotanical diversity as well. But without going too much into detail of that paper, because you can obviously read it, we sorted out that there are 297 Lamiaceae species in Southern Africa, which are in 42 genera. And the take-home message there was that 30% of the indigenous species have medicinal use records. 35% of all of them have been investigated pharmacologically, and only 29% have been looked at or have been investigated chemically. So the take-home message here is that many of the studies on the Lamiaceae are not necessarily ethnobotanically driven. So remarks on this paper is that the pharmacological data, if you read the paper, you will see that it shows that the traditional uses are supported by the pharmacological data, or the pharmacological data does support the traditional uses, especially in the use of species for antimicrobial infections and the like. Knowledge gaps still exist within the Lamiaceae in Southern Africa, especially in your larger genera, such as the Stachys and Syncolostomon, that have many or very little species that have been actually explored across the board. So Southern Africa holds considerable potential for further investigation of Lamiaceae species, probably others as well, but that can be investigated scientifically and for industrial exploration. So the objectives of this presentation will be to provide an overview of the ethnobotany, chemistry, and pharmacology of the indigenous Southern African Lamiaceae, highlight obvious knowledge gaps, and highlight findings that we have found in some of the species that we have studied. So there are three themes of this presentation. We'll look at the blue flowered stages in Southern Africa, the medicinal Southern African Stachys, and then Pseudodictynmus africanus, a well-known Cape Homo remedy. So the material and methods throughout the presentation are pretty much the same. For the volatiles, we used gas chromatography, mass spectrometry. Non-volatiles, we used ultra-performance liquid chromatography, mass spectrometry. And then for biological activity, we looked at the broth microdilution assay, as well as the brine shrimp lethality assay. So first one, we're looking at the tale of three stages, the three comparison between three ethnobotanically relevant or important Southern African salvia. So just to look at this genus, there are 28 species in Southern Africa, 14 of which are endemic to the region. These are the three species. So from left to right, we've got Salvia africana, Salvia chameleagnia, and Salvia dentata. Salvia africana and Salvia chameleagnia have been very well studied. Salvia dentata, on the other hand, is fairly unknown or not well known, and we are the first ones to have a look at the species. But as you can see, they look very similar, difficult to tell them apart. What is of diagnostic sort of value is the trichomes that they have on their calyces and on the corollas. So this just gives you an idea of the distribution, as well as the collection points of our study. As you can see, there is a slightly allopatric distribution of the species. So looking at the oils, we did hydrodistillation, and what we found was that Salvia dentata produced at least almost double the amount of volatile oil that's present in the other two species. And through the GCMS, we managed to identify 89 compounds across the three species. This just shows the main volatile constituents of these three species. As you can see, Salvia africana and Chameleonia are fairly similar, where Salvia dentata has the main volatiles made up of camphor, camphene, boronal acetate, as well as sharing two other with the other two species. So without getting too much into like the crazy data, these figures show, so from the multivariate analysis, we did a principal components analysis, and basically what we can see here is that Salvia dentata, Salvia dentata is sort of separate from the other two species which overlap quite greatly. And if we look at a dendrogram, we can see those exact same patterns coming through there. This is on the volatile data. So then looking at the non-volatile data, we can see that we observed 23 compounds within the methanolic extracts of these species. 13 we managed to tentatively identify, however 10 remain unknown, and that work is ongoing. Antimicrobial or biological activity, we can see that Salvia dentata has noteworthy biological activity against many of the pathogens tested, which in my opinion is does quite better than the other two species. And this might also ascribe to the traditional use, which is, I failed to mention, all three species are largely used to treat respiratory ailments. And so this sort of reinforces its use for those treatments. Toxicity, over here we can just see that it is not toxic and fairly safe for people to make use of. So if again we circle back, we look at the major compounds, we can see them listed, the volatile and non-volatile components. We know that from literature that's been published, they are potent anti-inflammatory, antioxidant, anti-cancer, bronchial dilatory effect, mitigate those, antimicrobial activity and analgesic activity. So again, this tells us that it reinforces the traditional use of these species. So about the remarks on this section is that although the three species are closely related, Salvia dentata does present a distinct chemical profile from the other two. The compounds have shown to be effective as therapeutical and antimicrobial agents, and they provide perfect examples of understudied species that can be tapped into for biologically active molecules. Moving on to the second theme, Stachys. Again, they've an overview of the genus, 42 species, 22 of which are endemic to the region. Here are some of the more well-known European and Asian species. I'm sure many of you may know these species. In South Africa, we have many, well, not many, so we've got several prominent ones, but the most prominent ones are Stachys rugosa, Stachys ethiopica, and Stachys flavescens. Medicinal uses for these species, mainly coughs, colds, influenza, mostly tea and tonic for general well-being, as well as aches, pains, and inflammation. So the aim of this part was to investigate the chemical variation between these medicinal species in Southern Africa, to report for the first time the volatile and non-volatile chemistry of these species, as well as to investigate the genetic and chemical relationships of these species. So this just shows a representative chromatogram of what we found in one of the species. This one sort of encompasses the compounds and profile against most of the species that we studied. So we identified 83 compounds in the volatile chemistry, and then in non-volatile chemistry, 27 compounds were observed, 16 identified, and 11 remain unknown. So again, if we compare the volatile and non-volatile chemistry, essentially they do have different patterns, but what we can see though is that the species still cluster together in fairly the same order. So there is some congruency between the different volatiles and the groupings that we get in these dendrograms. If we look at the molecular component, which we've just started to include now with the DNA, again, we see that with the preliminary data, the chemophenetic as well as the phylogenetic patterns are they are comparable across the three different studies that we have done. So this is ongoing, and we will be doing more intensive analyses once the data sets are complete. So again, the major compounds here, the non-volatiles, anti-inflammatory, anti-asthmatic, antioxidants, and immunosuppressants, where the volatile compounds are bronchially dilatory, analgesic, antimicrobial, anti-inflammatory. Again, these compounds are indicative of or reinforcing the traditional uses that they are used for. So it's the first account of volatile and non-volatile compounds in these species. Again, ascribed to the medicinal uses for which they're used traditionally. The volatile and non-volatile chemophenetic patterns vary from species to species, but generally there is some congruency across all of them. Genetic patterns have also shown to be similar to the chemophenetic patterns. Again, that is ongoing. Last one, the major volatile and phenolic compounds in catocrate, Thymus africanus, which is a very popular and important Cape herbal traditional medicine. Here we just see what the species looks like, and for some reason the distribution of the species has disappeared, but I have got another slide where it is on, so we'll get back to that. The medicinal uses of the species, again, coughs, colds, influenza, sore throats, respiratory ailments, aches, pains, headaches, heart ailments, cholesterol. So the main aim of this chapter was to investigate and report for the first time, again, the volatile and non-volatile chemistry of this important species. Again, for some reason, the distribution is not shown, but I will just show it here. It occurs in this region all the way into the Eastern Cape of Southern Africa. This was our sampling in the west coast of Southern Africa. We chose 4 different populations which we used, total of 12 populations, or 12 species, 3 individuals per population. The essential oil yield is very low for these species, but we managed to identify 52 compounds. There are a few more that still need to be identified, but we'll be looking at more refined methods in order to do that. If we look at the non-volatile chemistry, we managed to identify or observe 22 compounds, 11 tentatively identified, 11 are unknown. With the more prominent compounds, I've listed them up here. Again, potent anti-inflammatory, antimicrobial activity across the 2 different classes. So right now, with this information, we're beginning to understand the therapeutical use of these as traditional medicines. So for the remarks on this one, understanding the chemical composition sheds light onto the medicinal uses, as we've seen across the other 2 themes as well. A mixture of volatile and non-volatile compounds presents an opportunity for further investigation, especially with this species. There are many compounds that still need to be elucidated, so there's lots of scope for the future. Presentation conclusions. The Lamiaceae again offers an abundance of opportunity in a variety of investigations. There are links between the chemistry and biological activity, and the pharmacology is becoming more and more evident as we continue to explore the chemistry of these species. It opens up a variety of future studies and applications in various fields. So ongoing work, chemical analyses of medicinally relevant species, isolation and elucidation of compounds, phylogenetic analysis of key genera underway. If you would like to read more, we have published 2 papers. There are several more in process, so they'll come out later this year if you'd like to keep up to date with those. Those are my references. Obviously, a lot of funding and help has gone into this project. It is quite a big project, but first and foremost, I thank my supervisor, Prof. Ben, my institution, the National Research Foundation of South Africa, for funding me, conference organizers, and of course the audience, and my collaborators from the University of Stellenbosch and the University of Witwatersrand. And then of course, my fellow colleagues who I journeyed with 13,000 kilometers across the world and who are toiling together in this PhD safari. So thank you very much for your support. Thank you.